Hello everyone, this is Professor Chan for Math 1245 speaking. Today we're going to be going over section 4.1. So let's get started. It's going to be an introduction to exponential functions. So if you look right here, okay, you have what's called an exponential function in which you have b raised to the x. So let's kind of understand what's happening. Okay. So the idea is you have a base, b is called your base, and this x here is called my exponent. Okay. Now, we're in section 4.1, so this is going to be pretty basic. So all you're going to do is essentially just really plug things in. So we have, for example, let's just take a look at number 1. So for example, we have a function, 574 times 1.026 to the x, and x is years after 1974. So it says find India's population in the year 2028. Okay. So the thing we want to realize, right, is we to be a little bit careful. 2028 is, right, x is the years after 1974. So I'm going to do 228 minus 1974. All right, so I just throw it in my calculator. This is 54, so that is my x. Okay. So I'm just going to plug everything in. So I have f of 54 is equal to 574 times 1.026 raised to the 54th. Okay. And then I just throw it in. Okay. So just remember you want to do your exponents first. Okay. So I'll write that down. So it's 574 times 3.99055,965. So remember, I'm not going to round until the very end, and then I'll multiply this by 574. So I get the following here. 2,295. Roughly, it's 0.45, but obviously rounded to the nearest million. Okay, so there's 2,295 million people for India. Okay. Okay, let's just look at one more. And again, pretty straightforward. We'll just plug this in. So X is years after 1980. So this is in 2013. So I'm going to do 2013 minus 1980. I'm going to use my calculator right here. So 2013 minus 1980. And I'll get 33. Okay, so we have a special one where my base is what's called E. Okay, so when I plug this in, I have G to the 33. And when I plug 33 in, I have the following. Okay, so remember, rule is exponents. I have two exponents being right next to each other, so I'm going to multiply them out. Okay, so I have 32.7 e raised to the 0.7161. Okay. So to get your e, you're going to do second division. Okay. And you can type this in. The nice thing is with some of your calculators, you can actually go up and you can actually copy and paste. I'll do the caret button first, sorry, and then I'll copy and paste there. and then multiply by 32.7. So this is 66.92. Yeah, so that's my percentage for the following here. Okay, and then whatever units, make sure you label. Okay, so you can say 60.92%, that's fine. Okay, so now let's talk about an exponential function. Okay, so let's talk about this, right? What is 3 to x, right? So this is an example of an exponential function. So let's talk about what this even means, right? So I'm going to plug in some values. Let's kind of understand what's happening here, okay? So if I have, sorry, I'll make this x and y. Okay, so I have -2, -1, 0, 1, 2, okay? So the idea is if I plug them in, right, if I have 3 square, I'm going to get 9. If I plug in 1, I'll have 3 to 1, which is 3. 3 to 0, remember, is 1. 3 to -1, remember, if you have raised something to the negative power, right, you flip it around, so this is 1/3. And then 3 to -2, right, I'm writing it as 1 over 3 square, which will become 1/9. Okay. So I have 1 to 3, 2, 9. Whoops, sorry. 0, 1. -1/3, 1. 1/9, okay? And it looks like this if I sketch this. Okay? Roughly looks like this. Okay, so all of your exponential functions, what's going to happen is they're always going to flatten out, okay? So they're not going to cross 0, and then it's going to kind of essentially it just kind of like ramps up very quickly. So notice it's not like a line where it's very gradual, right? It just goes up increasingly. So one side of your exponent, right, it's just going to go up. It's going to go straight up to infinity. And the other side is going to flatten out. And primarily, you're going to have a horizontal asymptote at y is equal to 0. Okay? So a lot of your graphs are going to look like this too. And you can check too if you like put this in your graphing calculator. So if I go to y equals and I put in 3 to the x, I hit graph. So you can see it's kind of here. Okay. If I do like 5 to the x, same thing. It's going to kind of blow up. Okay. And you will have transformed types of graphs. So you could have like 3 to the -x. Okay, so now it's flipped backwards, but it's the same concept. Like one side's going to shoot up really quickly, and the other side's just going to flatten out. Okay, and then you may even have like vertical shifts. So I may have like 3 to the x, right? And then I did -6. Okay, so the -6, remember that's a vertical shift down. So the entire graph moves down. Okay. But remember, the shape should still be the same, right? It's gonna flatten first, and then it's gonna just kind of expand up or expand down. Okay. Okay. Yeah. So you'll run into some situations in which you'll have a transformed graph. Okay. Make sure you know how to do transformations, right, based off of your first midterm. But idea is, remember, if I do 2 to x, right? If I look at f of x, right? So -2, -1, 0, 1, 2. I would get 1/4. Let's see, 1/4. I'm gonna get 1/2. 1, 2, 4. Right. Now, if I go from f of x to g of x, I should realize this is a horizontal shift to the left. So I'm actually subtracting 1. Okay. Now, If you're not sure, remember, you can kind of graph both of them side to side, okay? So let me show you. So if I graph 2 to the x, and if I graph 2 to the x plus 1, watch what happens. So the first one's 2 to x. The second one is going to be 2 to x plus 1. So notice being shifted to the left. So since it's being shifted to the left by 1, remember we subtract our x values by 1. Okay. So, and then we can graph them. Do the best. I'm going to try to do the best I can. Okay. Can be a little bit tedious, especially if you're not a person who sketches a lot. Okay. But idea is going to flatten out like this. And then it's going to rise up. Okay. Okay, so just take some notes to understand kind of what's happening. Okay, so yeah, let's look at one more. So 2 to x, f of x, right? Okay. So this is the same exact problem, same exact original graph. Now notice I have 2x minus 3. So remember, this one is saying I am going down by 3. So 4 minus 3 is 1, 2 minus 3 is negative 1, 1 minus 3 is negative 2, 1 half minus 3 is negative 5 halves, and then 1/4 minus 3 is going to be negative 11/4. Okay, so again, just do the best you can. Oh, sorry, this should be negative 1. So it's going to look like this. So notice it's going to flatten out at y is equal to negative 3. I will have a horizontal asymptote at y is equal to negative 3. Okay. Okay, so since my sketch, since my sketch isn't the best, let me just kind of show this to you guys. Yeah, be careful when you sketch this 2 to x and then put the right arrow down and then say minus 3. It looks like this here. Okay, so right, it starts off flattening and then it just kind of explodes upwards for the following. Okay, so let's look at the next problem. So the last type of thing in 4.1, let me scroll down, is the types of word problems dealing with exponential functions. You have something called compound interest, okay? So this is your formula for compound interest. Okay? So P is principal. What is principal? That is your original amount. R is rate. You want to make sure you write this as a decimal. N is number of compounds per year. So let me explain this to you. So if you're compounding semi-annually, that would be 2. If you're compounding quarterly, that will be 4, because there's 4 quarters in a year. If you're compounding monthly, right, that would be 12, because there's 12 months. Weekly would be 52. And daily would be 365. Okay, and then T is times. Always remember time is always in years, okay? So, and then A is your new amount, okay, after you put money in. So it is like you're always putting like money in some stock or some bank, and it's going to add, okay, and then you get a certain amount back. So the idea is that we say here we have a sum of $10,000. So P is my 10,000. So idea is, right, you originally have $10,000 and you're putting that in investment, or you're putting it in a bank. Your R is 0.055 because that's your percentage. Notice it says monthly compounding, so my N is 12 and my T is 5, okay? Now, I have my formula right here, right? A is equal to P times 1 plus R over N raised to the NT. Okay? And so the idea is when we have this right here, we're gonna just plug everything in. So it's 10,000 1 plus 0.055 divided by 12 raised to the 12 times 5. Okay, so I'm going to first divide it by 12. I'm going to do the parentheses first. Okay, and I'm also going to do 12 times 5. So I can do the exponents next. Okay, so it's going to look like this. 10,000 1 plus 0.00. You do have to be pretty exact here. Raise to the 60th. Okay, I'm now going to add the 1. Okay, so I'm going to add 1. Now raise it to the 60th. So I have 1.31570337, and I'll multiply it by 10,000. Try to show your work as you're going along. Okay, this is important. I know this is easy for some of you guys to just throw in your calculator, but you just want to make sure you show your work to kind of understand what's happening. So you get $13,157.04. Okay, so this should make sense, right? Because the idea is if I'm banking or if I'm investing, I should get obviously more money out once I'm done after the 5 years, right? My money should not diminish over time. It should increase. Okay. Okay, let's look at one more example. Let's look at number 2. So it says a sum of $10,000 invested at a rate of 8%. So P is 10,000, R is 0.08, N is 5. Now it's quarterly, so whoops, sorry, N would be 4. My T would be 5, my bad. So we just plug everything in, right? So we have our formula. P times 1 plus R over N raised to the NT, or 10,000 1 plus 0.08 over 4 raised to the 4 times 5. So it's 1 plus 0.02 raised to the 20th. And then you can multiply this here. So I get $14,859.47. And that's my final answer. Okay. Okay. So this is called compound interest. Okay, with regular compounding, you also have one more type, which is called continuous compounding. So whenever they say continuous compounding, this is the formula you're going to use, okay? So notice here I have continuous compounding. So notice when you have continuous compounding as well, you don't have n, okay? So you only have to figure out P, R, T. Remember, E is just a number. It's 2.718. So we're given a sum of 10,000. So P is 10,000. R is 0.055. And my T is 5. So we just plug it in. So I have 10,000 e to the 0.055 times 5. I multiply 0.055 by 5. I have 10,000 e to the 0.275. Okay, so I have $13,165.31 when I multiply. Okay, now let's look at one more. So same thing, not too difficult. P is 10,000. I notice I'm doing continuous compounding again, so it is E. My R is 0.08, and my N is 5. So I'm going to do the following. I have 10,000 e to the 0.08 times 5, or 10,000 e to the 0.4. So I have 10,000 times 1.49182468, and then $14,918.25. Okay. So yeah, that's pretty much it. So shouldn't be that difficult to pick up. However, if you have questions, remember post on the discussion forum. But other than that, I will see you guys later.